All right, guys. Ready again. So doing statistics today. I don't know if we can finish 2 topics today. I don't want to rush it, because I have another class tomorrow. So we really have statistics, and what is the next one after that? Statistics. We did this the other day, relations and functions. We did all of this already. So we have geometry and trigs. I think this is the last topic on it. Geometry and trigs. So there's 2 topics you have left. So we might do the statistics today, and then do the geometry and trigs tomorrow. Or depending on how soon we finish the statistics, we might just do the geometry and trigs today as well. And then after that, is for you to go back through all these questions in the bank and make sure you understand every single question. As you can see, a lot of the questions are similar, very minute differences. And if you go about trying to memorize answers, you might just pick the wrong answer. So don't depend on that. You need to understand and know exactly how to answer each question. By the way, people online can hear me. Mr. Who's online? Ocean, can you hear me? Hello? Rihanna, can you hear me? See the screen?
Yes, sir.
All right, good.
Yes, sir.
All right, ready? Let's do this. Quiet now, quiet now, quiet now. Online and noise don't go well together. You know that already. All right, first question here. Statistics. It's 39 and 40 refer to the table below. We show the number of books that 58 students bought for school, or bought at a school. Bought at a sale, sorry. So these, when you're doing statistics, you want to know what is the score and what is the frequency. All right? So these are your scores. So this is the X, this is the F, your frequency. All right? So the number of books bought by this number of students. Sometimes all you can know what X is that it is in ascending order. That's so you can know what the scores are. All right? So those are your frequency, those are your scores. Question says, what is the mode? What is the mode for this data? What's the answer? So remember, the mode is not a frequency. No, it's not a frequency. The mode is a score. Mean, mode, median, range, interquartile range, semi-interquartile range. Those are our score values. All right? So it is a score with the highest frequency. Score with the highest frequency. Highest frequency is 13. And so this is the mode. So the mode is 5. What about that? Mode is 5. What is the answer for the median? So let's say the question asks for the median. Suppose it asks for the median. Oh, the second part asks for the median actually. Wow. Wow. The second part is actually asking for the median. They say, you know what CSEC like to set them up. So the second part says the median number of books bought at the sale is, we're going to find the median, guys. Let me rub this out. So identify this as a mode because it matches highest frequency. We're going to find the median. Somebody do it for me. Remember, that's the frequency, and these are the scores. The median is the value in the middle of the distribution. Since there are 58, since the total frequency is 58, there are 58 students in there. The median score is the score obtained by the one in the middle. But because there are 58, you know that you're going to average the 2 middle ones. You're going to have to average the 2 middle ones. So to find the 2 middle ones, you're going to have to count up your frequency. You have to count the frequency until you reach the number in the middle. All right, so do it for me. 58 students, you're gonna find the middle. Remember the position, let me do it down here. The position of the median, the position of Q2. Remember, it's half of n plus 1. Half of n plus 1, where the n is 58. You're looking for half of 59. But the n is equal to 58. So half of 59 is how much? Huh? 21.5. That's 21.5. So that's 21, 20, 21. Oh, sorry, 29. 29.5 term looking for. 29.5 term is the average of the 29th and the 30th term. 29 plus the 30th divided by 2. That is going to be your median Q2. 29 plus the 30th. How do you find the 29th score and the 30th score so that you can average them? How do you find? Remember now, these are the scores, and all this means that there are 9 trees. And then after those 9 trees, there are then 9 fours. So when you finish this set right here, you're now at 18. So this is your cumulative frequency. Remember, your cumulative frequency is a counting. You're counting your frequency so you can know how many valleys you have as you go. So you're going 18. They have to add 13 more for this group. There are 13 fives. 18 and 13 is how much? What is 18 and 13? 31. So it means then your median is also a 5. It means that the 29th is a 5 and the 30th is also a 5. But understand that? So the 29th is a 5 and the 30th is a 5, then the average is therefore 5. So that means then that the median is also 5. But understand that, Dora? Because you have to do this with other questions with different numbers. Do you understand it? But understand it? Sure. All right. Let me see if I can find another one then and give it to you. All right, look at this one then. This one said the following table are the scores obtained by students in a test. All right, first thing I want is the range. What is the range for the scores in this table? Remember, these are the scores. That's your frequency. What's the range of the scores in this question? Largest minus smallest, right? It's just 10 minus 2. It is 8. So the range is 8. What is the modal score? What is the modal score? What's the modal score? Also 8. But that's the highest frequency, don't it? Highest frequency corresponds to 8, right? So the modal score is also 8. Right here. All right. Work out the median for me now. So for the median, you need to know the number of scores. You have to add up the frequency right here. Add that up. Add this up and tell me what the median score is. Work out the median score for this one for me, please. Somebody work it out for me. The median score. Give me now 30 seconds. Work out the median score for that data, let me see. You didn't ask it. Nobody get it? Score in the middle of the distribution. Anybody? All right, the first thing, remember, you want to score in the middle. All right? So how many scores do you have? You have to add up this to know the number of scores. That looks like it is 32. So another way to find the middle term of 32, you can look at it like this. Look. So like you have a 32 scores, right? 132. I'm going to divide it in half. It's ready. You divide it half and half to find the middle. You divide it 16 up to 16, and then you have some 17 up to 32 is the next 6. So the first 16 scores down here, and then you have the next 16 scores up here. But understand that. So your median is in between right here. If you're calculating it, that would be the middle. That would be your Q2. So right here is between the 16th and the 17th. Remember, when there's an even number of terms, you're averaging the 2 in the middle. So the median is the average of the 16th and the 17th score. Average of the 16th and the 17th score. So this is going to be equal to the 16 plus the 17 divided by 2. Question is, what is the 16? To get the 60, you have to count the frequency this way. Add it up. So you can put in a cumulative. You don't have to actually put it in. You can actually count until you reach 16, you know. Add up this frequency till you reach 16. But I'm going to write it here still. Cumulative frequency. Cumulative frequency. Cumulative frequency, remember that we are counting how many values you have as you go from value to value. First, you have 8 twos. When you finish putting in the twos, you have 8 values so far. You have 4 threes. So you finish putting in the threes, you know, have a total of 12 values. Then you have 6 fives. So when you finish putting in the fives, you know, have a total of 18 values. So you see, you already passed the 16th and the 17th value. So in this example again, the 16th value is one of these. One of these 6 values in this group. So the 16th value and the 17th value are both in that set here. So you finish 12 and you go all the way up to 18 values when you finish putting in the fives. So it means that the 16th value is a 5 and the 17th value is also a 5. And so you're going to average those 2 values now to get the median. So it's a 5 plus a 5 over 2. Well, if two of them is a 5, they must average 5. So the median will be 5. The median for this data would also be 5. But understand that? Score of 5. All right. Next one up here. Do it for this one for me now. Give me, for this data, is the same data. Let me see the same data. 2, 8, see the same table. No, different, because that's an 11 right there. So it's different. That's an 11 right there. And this is a 12, where that was a 9. All right, so it's almost the same, but not quite. So do it to this one for me. Give me the mode, and give me the median for this data. Come on, do it for me. Mode and the median. Mode and the median. Work out the mode and the median for this data. Youngster, work out the thing now, man. First, you have to know the total frequency so you can know where is the middle. So these are your frequency. These are your scores. So know how many values after you have to add up the frequency and then try to go to the middle. If it's an odd number of values in the frequency, the one in the middle is the median. An even number of values in the frequency, you have to average 2 middle ones to get the median. You cannot learn without doing the thing, guys. You have to actually do it to learn how to do it. You cannot watch me do it. You have to actually do it yourself. Come on. You want to get 6 out of 60 in the multiple choice, so now you don't know what's coming on the exam paper. Make sure you know how to do the questions. But not finish yet. You get the median. What's the mode? First question, what's the mode? The mode is 8 because this is the highest frequency. Highest frequency corresponds to the mode. Or the mode is the value with the highest frequency. So the mode is 8. So the answer for this one is 8. Median now, median. What is the median we're asking? So the first thing you want to know how many values I have so you can go to the middle and get the 2 in the middle. So what does this add up to? Sum of the frequency. N equals what? When you add this up. 35. So you get 35. You divide 35 half and half. You get 17, 17, don't it? And 1 in the middle. That's all. So the 18th value is the median. Or you could say the position of the median is half of 35 plus 1. That's half of 36, which is the 18th value. 18th value is the median. Or you could say they divided 35 half and half. So you get 17 at the bottom, 17 at the top, 1 in the middle is the 18th value. So you need to count out the frequency this way now to find the 18th value. Looking for the 18th value. So that will be a cumulative frequency, which is your counting. Remember, cumulative frequency is a way of counting the values that you have. By trying to find the 18th one. So you finish this, you have 8 values so far. 8 plus 4 more makes 12. So you finish putting in the 2s and the 3s, you have 12 values. Then you need to put in the 5s. There are 6 of them. That takes you to 18. So the 18th value actually is a 5 as well. So the median is a 5. But I go to that. So the median is equal to a 5. But all right to that, all these medians been 5. All right, let's continue. The median for this one is what? Easy. The median for this set of values is what? How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So since you are 10, you're going to divide it half and half. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. The median is right in between there, so. Average of those 2 middle values. See that? Which is what? 6.5, right? Q2 is 6 plus 7 over 2. I can know that 6.5 is the number comes right between 6 and 7. Good? Beautiful. Next one. This one says there are 11 students and represent to score what 11 students are coming. What is the mode? What is the mode? Huh? The mode is 3. 1, 2, 3, 4 of them. All right, 3. What is the median? Median. Somebody tell me the median. What is the median? They say 8 right here, sir. That's what I said. But I say 8 is the median. What do you say? Exactly. You can't find the median until you put them in ascending order first. Come on, man, just can't miss on those things. You have to put them in ascending order first. The median, the interquartile range, the quartiles, and including the median. You have to put the data in ascending order first before you can identify the median. Come on, man, you can't make them basic things and get you know at this stage. you have to have the data ascending or descending order first. Go to work it ascending order. So they put them in ascending order first. So the lowest value is the trees, right? 3, 3, 3, 3. 4 of them. 1, 2, 3, 4. Next value is a 5 right here, don't it? Are they in the 4s? No. Then we have a 5. Look like 5 is a median. Again. The next one is a 6. There are 2 6s here. 6 and 6. Then there is a 7. Then there are 2 8s. 1, 2, 3, 4, 5, 6, 7. All right, there are 2 8s, right? 8 and 8. And then there is this 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 values. So it's 5 and 5. Divide the 5 and 5. So this is the median, Q2. Q2 equals 6 for this data. Put them in ascending order first. Remember that, guys, ascending order first. All right,
Sir,
yes.
what does the Q2 mean?
Second quartile, which is also the median.
Oh,
Right, so okay, so since we're on it then, somebody tell me what is the interquartile range? Good question. What is the interquartile range for this data? What is the interquartile range for this data? It becomes Q3 minus Q1. The Q3 is the middle of the top half. The value in the middle of the top half, which is this one. That is your Q3. Let me shift this down a bit. So this is your Q3. And the middle of the bottom half is your Q1. So the interquartile range will be the 8 minus 3, which is still 5 again. All right, I'm not 5, sir. 5 again will be the interquartile range. And the semi-interquartile range would be half of this. In mathematics, semi generally means half. Semicircle, for example, half of a circle. Generally speaking, the word semi means half. So half of the interquartile range is the semi-interquartile range. So tell me for this one up here, this one. What will be the interquartile range for this one? This one. What will be the Q3 and the Q1? Middle of the top half, bottom half. Watch this now. 2, 4, 5 values in the bottom half. One in the middle, this one will be Q1. And this one will be Q3. So the interquartile range, if they wanted it, will be 7 minus 5, which is equal to 2. Interquartile range. And from this, the semi-interquartile range will be 2 over 2, half of the interquartile range, which will be 1, if they wanted the semi-interquartile range. All right? How could we get the median from this table? The quartiles from this table. We know that the median is that one, but how could we get the other quartiles from this table up here? How could we get the Q3 and the Q1 from this table?
By using the formula, sir.
You can use the formula to find the position of the quartiles and then count to find them, right? All right, let's do it that way. So for example, the position of Q1, not Q1 is 7, the position of Q1 is 1/4 of the n plus 1/3, which is the 35 plus 1. 1/4 of 36. How much is that? 1/4 of 36 is how much? 9. That's the 9th value. The 9th term. All right? Or it could be the middle of the bottom 17 values. And the position of Q3 will be 3/4 of the same n plus 1. That will be the 27th term. So look up here now. The 9th term is a what? What's the 9th term in this table? Remember, so we reach 8 values and then reach up to 12 values. So the 9th value is here, so don't it? The 9th value is a 3. The 9th value is one of these, right? This will be the 9th value. Q1 will be equal to 3. Then the 27th value, to keep counting. We reach 18 values here, so let's go back for the purple. Then we're looking for the 27th value now, right? So we'll add 3 more and we reach 21, right? Then we add 12 more, we reach 33. So the 27th value is one of these 12 values right here. And after we reach 21 values, they need 6 more values. The 6 more values is one of these 12. So it means that this value now is a Q3. This will be a Q3 right here. Q3 will be equal to 8. See that? And so for this data up here, the interquartile range would be 8 minus 3, which is equal to 5. For that data, everything is 5. They like 5 in these questions. So be coincident. But after that, all right, let's continue. Ready? Question says, the pie chart below not drawn to scale shows how 12 hours, our students use 12 hours in studying English, math, French, and geo. So this is math, this is English, this is French, this is geography. All right. The amount of time spent on maths is what? Approximately. So it's 12 hours we are total. This is the sector for maths, and they're asking us approximately, in other words, on site. How much is used for maths? 3 hours. That is just 1/4 of the whole circle, don't it? Everybody agree with that? So maths is 1/4 of a circle. Or you could say 90 that is anyway you want to cut it, that's 1/4. So it will be 1/4. Let's write it this way. Math would be 1/4 of the 12 hours, which is 3 hours, right? Right there. Gotta go to that. All right, next one. This one for me now. This question says, it shows a pie chart which shows the popular games played by 720 students. 720 students. And they give us this information. Now look, they give you in percentage and also give you in degrees. Now you have to decide which one you're working in. Either gonna be working in degrees, or gonna be working in percentage. If you're working in degrees, total angle in there is 360 degrees. What's that I write? 360. If you're working in degrees, your total is 360 degrees. If you decide that you're working in percentage, then you're working a total of 100%. Your choice. Your choice. You determine whether you're going to be working in percentage or you're going to be working in degrees, because the data is presented in percentages and also presented in degrees. All right? The question says, how many students play cricket? How many students play cricket where cricket is over here? So in other words, you want to work out how many students play cricket. Total of 720 students. Talk to me. Work it out and tell me what you're going to use. Right, it says 90 degrees, and I can see that one right there is 90 degrees. That 90 degrees is 1/4. 1/4 is what percentage? 25% if you're working in 20, if you decide that you're working in, if you decide that you're working in percentage, look at it. If you decide that you're working in percentage, then right here, so 90 degrees is 1/4 of the whole circle, which is 1/4 of 100%, which will be 25%. And this 36 degrees is 36 over 360. 36 over 360 is 1/10. 1/10, if you're working in percentages, 1/10 of 100% is 10%. So 36 degrees represents 10%. So I feel it is easier to work in percentages in this question. And the total is 100%. So come on, work it for me and tell me over here. If you work on the percentage for over here, you do that percentage of the 720 That will be the number of students. All right? Come on, do it for me. Work it out. How many students play cricket? Working in degrees or working in percent? I just need it easier to work in percentages. Convert everything to percentage. Based on these numbers. And the total percent must be 100. That's what they know. The total percent must be 100. Yeah, what's up? I'm in a class. I'm in class. Got to finish? Got to go? All right, let's work it out. I'm going to work in percent. I think it's easier to work in percentage rather than in degrees. They're working to a total of 100, right? Youngster, hey. You see, do what? All right, so 20, one quarter of 100% is 25%. You know, this is 25%. Agreed? And this is 36 degrees out of 360. That's 1/10. 1/10 of 100 is 10%. So right here is 10%. So you add up these three, how much you gone? What you gone? If you add up these three, how much you gone? 65%. So over here, so is how much? 35%. So you need 35% of that now. 35% of that. So you can get 35% of that without the calculator. Quick and fast. 252. But you can get it without the calculator. You work it out without the calculator. Huh? You just do it. Divide by. Wait, you do 35 over 100 times 720. That's what I do. 0.35 times 720. Okay. All right. In the exam, I guess another way to do it is say, okay, I want 35%. 10% is 72. So 30% is 3 times that. 30% is 3 times that. 3 times the 70 is 210. 3 times the 6. 3 times the 2 is 6. That's 216. Agreed? And then 5% is half of this. 5% is half of this, which is 36. And then add them up. 30% plus 5%. I mean, you don't have to do it this way, but that's going to give you the same answer. 252. But you can't use a calculator. But if you want to do 0.35 times 720 and get the same answer, no problem. But sometimes without a calculator, you break down calculation, simple number. 10% of 72 is just 10% of 720 is 72. So 30% is 3 times that. 3 times 72 is 3 times the 70 first, is 210. And then 3 times the 2 is 6. 210 plus 6 is 216. And then 5% is half of the 72, which is 36. It's 216 plus 36. I can't calculate, but you could always just multiply that. Not a problem. All right, good. Next one, this one for me now. Almost the same question. It is the same question. But this time I give you everything. How many students play cricket? So it's the same question really. So they give you 30% for basketball, which you had a 30% of here. They give you 25% for football, we had 25% of here for football. And they give us a 10% for tennis. So it's really the same question, guys. Good? I'm not showing you. So the same question over here becomes 35%. All right? And 35% becomes the same 252. All right. Same question on a different paper. Here you go again. This time I change some number. This is now 35%. This is 30%. This is 10 degrees. And they're asking us for football. So you see that it's the same question, but they give you this now. They give you the cricket now. See that? They give you the cricket now. And they're asking you for, it says, and also the number of students is less, 180. All right? So if 180 students, 180 students play football, how many students are there in the group? Wow. 180 play football. Kind of easy. 180 play football, how many are there in the group altogether? So if you realize that the football is just 1/4 of everything. So 1/4 of everything is equal to 180. Same exact question really, I think, Right? So football, the 90 degree right here is 1/4. Or if you add up these and subtract from 100, you're gonna get this as 25%, just the same. 25% is 1/4. So see there, 1/4 times the total is 180. That's what they basically saying. 1/4 of the total is 180. So if you want to find the total, just multiply this by 4. Multiply that by 4. All right, so the total comes 4 times 180. What's that work out to? Same 720, don't it? So it's the CSEC just set by the same question. Just flip it and turn it on. But I can't bother set a new question. Just set the same question and just look out some information and stuff. That's how they do it sometimes. All right? But you want to know how to do it in case they make a change. You want to understand what you're doing. You won't go memorizing questions. All right? Next one. Miss Clark arranged the 15 test scores of her students in order, size, and selected the 8th score for reporting purposes. Which of the following statistical measure did she obtain? Which one? The median, the one in the middle. We have 15 scores. The one in the middle is the 8th one, right? See, there are 15 scores. 15 scores. So you have 7 down here, so 7 up here, so. And you have the 8th one in the middle. The 8th one in the middle. All right, 7, 7, and the 8th one. You have 7 scores down here, so 7 scores up here to make 14. Then the 1 score in the middle. Plus 1 in the middle. Q2 is the one in the middle. That's the median. Are you okay with that? All right, come on, I have to do some work, Here goes. It says, in a box, there are 8 red, 7 blue, and 6 green marbles. 1 marble is picked up randomly. What's the probability that it is neither blue nor green? What's the probability that it is neither blue nor green? If it's neither blue nor green, then you want it to be red, no sir? So it's basically the probability of it being red is the answer. But that's not that. You don't want it to be blue. You don't want it to be green, which means you want it to be red. So it's really about the probability of it being red. But I get me? So this is equal to the probability of being red. The probability of red. That's what it is. Which is what? Huh? How many days total? You have to add up these to get the total. 21? 21 total? So it's 8 over 21. Answer is 8. All right. Next question. This one. All right. So she have 8 marbles. She have 8 red marbles, 7 blue marbles, and 6 green marbles. And she's gonna draw 2 marbles. What's the probability of getting a red and then a blue without replacing the marbles? What's the probability of getting a red and a blue without replacing the marbles? So she take out probability of taking out a red and then take out a blue, and she's not replacing them. So tell me that probability of getting a red, probability of getting a red and a blue without replacement. Then I want to give me a same thing, probability of getting a red and a blue with replacement. With replacement, meaning she took out the red first and then she put it back. And then she wants to go to blue. That's with replacement. Probably get a red and a blue with replacement. Write them out for me. So remember, generally speaking, in probability, and means that you're going to be multiplying the probabilities. This or, you're going to be adding the probability. So if you wanted to make a draw, and you wanted a red or a blue, then you would add the probability of getting a red and the probability of getting a blue. A red or a blue means either one of them. So you basically go for the total. Get me? So generally speaking, in statistics, you want something and something, you're going to multiply the probabilities. You want something or another thing, they're going to add the probability. So it's and you multiply or you add. Generally speaking, there are some other little conditions on it, but let's just work with that for now. And the then, this, then, that, first thing and then a second thing, counts as an and in probability theory as well. So it works just like an and to multiply. But this and then that, you're going to multiply consecutive events. So tell me now, what's probability of getting a red and a blue without replacement? Let me see if we can shift this up. I'm going to do it. Anybody? Anybody have anything from anybody?
56 over 420.
Huh?
So it's 56 over 420.
All right, hold on. Not hearing you clearly. All right, without replacement, guys. Let's do the without replacement. So there are 21 balls in the bag. Let's say these are marbles in a bag. And she wants to get a red first. There are 8 reds. So probability of getting a red on the first try would be 8 out of 21. But she's not putting in back the red. So there are now 20 marbles left in the bag, in which there are 7 blues. So you have to multiply that now by 7 over 20. And you work that out. But understand that? That is a without replacement. If it is a with replacement down here, with replacement, the replacement gone. Then again, still 8 out of 21 to start. So you take out you have a chance of getting 8 out of 21. So you take out the one red marble. We're putting it back. So after you put it back, you still now have 21 to draw from, but it's a blue you want now. So multiply that now by 7 out of 21. That is the difference with replace. With replacement, you take out the red, imagine that you take out the red marble first, and you put it back. So when you put it back, you're gonna draw now and try to get a blue. And to get a blue is 7 out of 21 now, because there are now 21 marbles in the bag when you do the replacement. But understand that? That's the difference between with replacement and without replacement. All right? The total that you're drawing from has been reduced. But I got it that? All right, good. Let's continue. Because they're asking this kind of question nowadays, so you can look out for something like this. All right, they're asking this kind of stuff on the paper too. Ready, some bar charts, and it's a histogram actually. This one says, it refers to the following chart, which shows the amount of fish bought in kilograms by the first 60 customers at the fish market. How many customers bought at least 6 kilograms of fish? How many bought at least 6? What the term at least means? It means 6 or more, don't it? Work it out for me. So how many bought 6 or more kilograms of fish? Note that this is the mass of the fish down here. And this is the number of customers. And you're counting how many customers bought at least 6 kilograms. So at least 6 kilograms is referring to these out here. So you want to find how many persons bought 6, how many persons bought 7, how many bought 8, how many bought 9, and how many bought 10. And you add them up. But understand that? All right. So how many bought 6? This is 11 up here. So right, let me zoom it up. This is 11. Half between the 12, 10 and the 12 is 11. This one is 5. This one is 4. This one is 7. And this one is 3. They're adding up those to know how many persons bought 6 or more kilograms. And that is this 10 right here. So how much? 20 that. 30 that. 30. Good, thank you very much. That's 30. So it's 11 plus 5 plus 4 plus 7 plus 3, which add up to 30. All right. Same question down here. The median amount of fish bought by the customer. Same diagram, you know. Same diagram they gave on this question, but now they want the median. The median amount bought. Come on, work it out for me. But this same data, what's the median amount bought? Come on, look at it. What's the median amount bought? Remember, this is the frequency up here. And this is the mass. So you have to add up how many customers are there in total. Did they tell us in the question? 60 customers, right? So they help you. So the total frequency is 60. So you want the one in the middle. There are 60 customers. So you want the one in the middle. So you cut the 60 in half, you get 30. So the bottom half is 30, and the top half starts at 31. The bottom half ends at 30, the top half starts at 31. Because there's an even number of customers there. Customer in the middle really is like the average of the 30th and the 31st. So you need to know the weight bought by the 30th and the weight bought by the 31st, and you average them. So you're gonna have to count up the frequency now. Remember, the frequency are the values up here. The values up here are the frequency values. You want to reach 30th and the 31st. But that's not that. Let me show you again. 60 customers in all, 60. Total 60. So I can take the 60 and divide it half and half. 30 at the bottom and 30 at the top. This is from 1 to 30. And the top half starts at 31 to 60. That's a quick way to divide it up. 1 to 30, 31 to 60. 60 values. So the median would be the one right in between here. Between the 30th and the 31st person. You want the average of the weight taken by the 31st person and the 30th person and the 31st person. So the 30th weight plus the 31st weight divided by 2. So how do you get the 30th weight and the 31st weight? Or the how do you find the 30th customer and the 31st customer? So these are the customers. You have to add them up this way. So you have 11 up here, so. And then you have 10 right there. So much you gone so far? 21, don't it? Then the next weight is 5. That's another 9 person. How much you gone there, so? 30. So this is the 30th weight, the 30th. This is the 30th weight. So the 31st weight start right here, so don't it? But I can see that? The 31st, so this is the 31st weight. And so you're averaging the 5 and the averaging 5 and 6. 30th weight, at the 30th customer bought 5 kilograms. The 31st customer is the first one in this group of 11 persons. But that's not first one in this 11 persons, the 31st. Bought a weight of 6 kilograms. So this becomes 6 plus 5 plus 6 over 2, which is 5.5. 5 plus 6 over 2, which is 5.5 kilograms, the answer. Right here. Do you understand it? Can you do it on your own? If you change the numbers, can you do it? All right. Do this one for me then. This one says, item 39 refer to the following histogram. We show the number of children aged 4, 5, 6, 7, and 8 who took part in a survey. What is the modal age? Easy, this one easy. What's the modal age in this one? The one with the highest frequency. See there? 7. Don't put 5 in. The mode is a score, not the frequency. This is the frequency. Remember, the mode is not a frequency, it's a score. This data is about ages, years. The data is in years. So the mode is an age in years, not a frequency. So these are your scores down here. Scores are always on the horizontal axis, actually. So these are your scores. And up here is your frequency, the number of students who have those ages. So the highest frequency is this one. Highest frequency is that one. Correspond to this age. But again, but I understand that. Good. So that is 7. How many students took part in the survey? How many students took part in the survey? You have to add up the frequency to know, right? So this is 3 right here, so 4 right there, so 2 right there, so 5 right there, so and 1 right there, so add them up. So it's 3 plus 4 plus 2 plus 5 plus 1. What add up to? 15, I say? Yeah, that was like 15. Can't be 75, and it's not 550 for sure. But good? All right. This one. A child is selected at random. Same question. A child is selected at random. See? On a different exam paper, do the same diagram, and I ask all these questions on the same diagram. Who they? Jesus Christ. I don't know what we're gonna do with it. Down here. A child is selected at random. What's the probability that a child is more than 4 years old? What's the probability that a child is more than 4 years old? Look at the table here, so the histogram. What's the probability that the child is, let me say, more than 4? Oh, more than 4, more than 4. Yeah, more than 4. Talk to me. The probability that the child is more than 4. Huh? D, no answer. So the ones that are more than 4 are these, don't it?
I'll go 15, sir.
These are the ages that are more than 4. These are the number of persons more than 4. I'm going to do it now. It's so. Those are the ages more than 4, don't it? Say add them up, right? So these add up too much. Those add up to
12.
12. So it's 12 out of, what was the total again? Total was 15. So it's 12 out of 15. Which reduces to 4/5 if we divide 2 by 3. So the answer is D. All right, good. All right, this one for me now. This one says, item 41 and 42, refer to the following chart which shows the number of books 58 students bought at a sale. 58 is the number of students. Everything important. But these are your scores down here. This is your frequency up here. Mean, mode, range, median, interquartile range are values down here. Right? So your data is the number of books and frequency is the number of students. Question says, how many students bought exactly 4 books? So exactly 4 books right here, so 9. What I give it that? Beautiful. 9. This answer is 9. Next one. The median number of books bought by the students. All right, come work out for me. The median number of books bought by the students. Come on, do this one for me. The median number of books bought. There are 58 students. 58 students. Remember, I'm going to divide the 58, 29, and 29. Divide 29 and 29. First, the bottom 29 and the top 29. So the median is the average of the 29th one. That's the last student in the first half. And the first student in the top half will be the 30th student. So I've averaged the number of books bought by the 29th student and the 30th student. So if I count up the frequency until you reach 29 and 30, come on. So which group, which are these columns is the 29th and the 30th student? Add them up. Right here says 8. Right here says 9. Up here says what? 13. Here says 9 again. Okay, mistake. No, here says 11. And here says 10. And then right here says 7. You're trying to reach the 29 and the 30th student. Again, remember if it's 58 total, you can just divide it half and half like so. Bottom half of 29 and the top half of 29. So this is 1 to 29. The bottom half, 1 to 29. And the top half starts at 30. Top half starts at 30. 30 to 58. So you have 19 students. You have to, 29 down here and 29 up here to add up to the 58 students. And so the median is right in between here, so. Right? The median. So you do the 29th plus the 30th divided by 2. So you have to find the number of books bought by the 29th student and the number of books bought by the 30th student, and you average them. Helping the next one, we're not going to do it to myself now. Go on, tell me one again. Sound fairly easy. What's the answer? Huh?
5, sir.
Where you get 3? Where you get 3? I see him people do all the other ones I'm already. See the number of students them up here, sir. So when the first group done, all the students who buy 3 books, is 8 of them. Then you have 9 persons who bought 4 books. They got 17 so far. So you don't reach 29 yet. They have 13 students who bought 5 books. So on 17 so far down there, so plus 13 more, much that? Let me write, sir. This one is a 17 so far, right? 17 so far, right? And they have 13 students up here, so 13 more. So you reach 30 students. So when you finish putting in all the 5, they reach 30 students. So the 29th student is a 5, and the 30th student also bought 5. So it's 5 plus 5 over 2. Huh? You have to average it. They still couldn't get 3. But understand that? So the 29th student bought 5 books. And the 30th student also bought 5 books. It's done. Also bought 5 books. And you divide that by 2. But if it's 5 and 5, the answer must be 5, right? So the median is 5 books. Median. Oh man, them things are too easy, you know, man. You can't get them things wrong, you know. I have so many examples. Tell you now, if you watch me do 100 of them, and you don't do one for yourself, you won't be able to do it. No matter how much time I do it and explain it. You have to do it by yourself in order to be able to do it. When you watch people do high jump, you can learn how to high jump after watching people do high jump. You never go to do the high jump yourself. And the same thing with the maths. You cannot watch people do maths and learn. If all that was needed for everybody to learn maths was to watch people do maths, everybody in the whole Caribbean would have been okay with maths. Because they have so many people online teaching maths online every day. I show people how to solve maths. So many people online every day doing maths all over the place, and still Caribbean pass rate is 30%. Why? Because everybody depending on watching all these people online solving maths. That's not going to do it. That's not going to do it. When you watch people solve maths, I say, I understand it, I learn it, it looks so easy. You know, easy to do it yourself. When you do it yourself, it's really easy. So when we do the example, you have to do it yourself to be able to do it. No matter how many of them I do, if you don't do it yourself, you won't be able to do it. So you have to toil through and get it right and do it yourself. And oftentimes, if you do one by yourself, then you're good after that. But the problem is some of you don't even want to try to do one for yourself. You just want to see surgery and say that's good enough. That's not good enough. If that was good enough, everybody in the Caribbean would have passed. Because there are so many persons showing people how to do the best every day, all over the place. Hey, anytime I come to, I want to say, what is paper and pen and pencil? This is not a sit down and watch, sir, do the question class. Let up on it. Let's go. Next one. Cumulative frequency curves now. Hey, I'm not work about the one of the question and I'm not joking for the exam next week, you know. Next question. This one says it refers to 40 and 41 refer to the following diagram, which is cumulative frequency curve. based on the marks of 200 students. So this now, these are your students. These are the scores that they got less than. Remember, cumulative frequency curve, you know, really show you the exact score obtained by the students, because it is usually obtained from grouped data. And in grouped data, you don't know the actual scores by the students. What you know is how many students scored less than a mark or less than or equal to a mark. So the cumulative frequency curve can show either how many students got less than a mark, or it can show how many students got less than or equal a mark, depending on which data was used to plot the graph. When in doubt, use less than. So if you don't know, I would say this is showing me less than marks. It is showing me how many students scored less than any mark down here. So for example, if I want to know how many people scored less than 30 marks, come down and then I'm going to put in less than for you know. You have to know. That's not showing you really how many students scored 30 marks. It's really showing you how many people scored less than 30 marks. That's what it's showing you. Because I don't know the actual marks scored by the people. You get me? So if you want to know how many people score less than 30, you come to 30 or so, and you come up on the graph, and you read it across, and you see how many persons that, what number of persons that. Because these are the persons, these are the students in ascending order, from the ones who score the low marks at the bottom, the ones who score the high marks at the top. They're in ascending order. Right? And for example, if you want to know the mark, if you want to know the mark that's, for example, 120 persons got less than, 120 students got less than. Because these are the 120 students down here. You want to know the mark that they got less than? You come across on the graph for 120. You reach a graph right here. And you read it down on the x-axis. Right there. And this on this scale, this is 10, 30 to 40. There are 10 lines there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines there. So each line is 1. So this is actually 39.5, 39.5. So 130 students got less than 39.5 marks. That's what that would mean. You have to know how to read the information from a cumulative frequency graph. You don't know what they're going to ask in the exam. Let's see what this one says. The median mark scored by the 200 students, easy. This one is a very easy question. There are two parts. So the median mark is a mark that 100 students scored less than, approximately. All right? But there are 200 students. That's why it's 100 students, half of the students. Right? So you come to the 100 mark, which is right here. That is the position of Q1. Q2, sorry. 100. That's a 100 students. Right? So 100 students approximately scored less than the median mark. So you come across on the graph to find what that median mark is. And you look carefully, it looks like right in between here. Read it down. Read it down. There. That's 30, 35, 36, 37, 37.5. 37.5 marks. Wow. Better go. All right. Next one. The highest mark scored in the test. The highest mark scored in the test. What's the highest mark scored in the test? What's the highest mark scored in the test? You come up on the graph. The last student approximately scored the highest mark. So it look like 60 based on this. It can't be 50. So it's basically up here. The last student scored the highest mark approximately. So if you sum it up here, so 60. It can't be 50, guys. You have people pass 50. See there? You look at it. After 60, the next answer they have was 50. Can't be none of these, these total out of it, Right? So because the marks only went up to 60 on this graph. So if it was 50 was the highest mark, that's not true because you have some students up here that scored higher than 50. There's some students up here that scored higher than 50. Is that they couldn't put 50. So that's says 60. This is an easy question. I must have made a sense, but anyway. But it makes sense that people going to get around it. 60 marks, the highest mark, oh dear. Oh dear, sir. First point up here. All right. Those are the two questions. Next one. What is the interquartile rate? So you see, for the same question, let me see this. This was just 40 to 41. I've seen on other papers, for the same graph, they ask other questions. So these are two questions that would have asked on a paper. So I put back 41 from another paper, 42. This again is from the same graph, from the same graph on another paper. So the 41 and 42 is the same graph on another exam paper. You get me? All right. So for the same graph on another exam paper, they're asking us for the interquartile range for 200, and then on another paper, they're asking for the lower quartile for the 200 marks on another paper. So ready? We're going to get the interquartile range. Interquartile range is what? No, work it out for me. You want the interquartile range. Let me tell you, it is Q3 minus Q1. So you're going to have to find Q3. And then over here, the lower quartile is just Q1. Q1. Let me zoom up my graph on the screen and work out right there. Let me take this out. We don't need the median anymore. See there? Maths it out for me. Estimate based on that where the Q3 is and the Q1 is. Tell me that. And use the two of them to find the interquartile rate. Come on, give me a minute. 200 students, 1/4 of 200, 3/4 of that. Finish. 200, position of Q3 is 3/4 of the 200. Position of Q1 is 1/4 of the 200. And you have to read over on the graph now to get the mark. Come on, do it. Look at the graph and tell me what it looks like here. Anybody have any estimate of the answer? So the answer they give down here, 12.5, 30. These are the answers they give. All right, ready? Ready? All right. So what's me now? To get the quartile still, right? You can say, okay, it's 200. So I can divide a top half and a bottom half right here. This is 100, right? So you have a top half right here. And you want halfway of this top half between 100 and 200, which is clearly 150, right? That's another way to look at it. And you have the bottom half from 0 to 100. So half between 0 and 100 is 50, right? but you could still do 3/4 of 200 for the upper quartile, 1/4 of 100 for the position of the lower quartile. All right? So let's do that. So 50 is the position of Q1. 1/4 of 200 is 50. All right? So let's look at it now. This is 40. This is 60. So right in between here, so it's 50. Want to get that? So this is the position of Q1 right here at 50. So you come across on the graph. Right on there, so it look like 30. Read it down. So this 30 looks like my Q1. I'm going to take that as my Q1. So the answer for over here, they only ask for the quartile, is 30. Bam. But I need Q3 to get the interquartile rate. I need the position of Q3 now. 3/4 of 200. 3/4 of 200 is 150. So you come and look for 150. Be careful now. So this is 160, 151. This is 120. Right here says 140. But I will put this as 150, you know, like I don't have no sense enough. I don't know 150. Halfway between 120 and 160 is 140. And then halfway between 140 and 160 now is 150. So 150 is actually right inside here. So 150. This now is the position of Q3. Not Q3 itself, no, the position of the upper quartile. So the 150th student scored less than the upper quartile mark. So come across on the graph right in between here. Till you reach the graph. Looks like on that line approximately. I'm gonna just work with that line. All right, looks like right on this line. And I'm gonna come in down here and read it. And if you do it and get a value close to this, then you work with that value. Because remember, we're estimating. You come down on this line. And this mark right here is that looks like a 43. 42.5. Q3. That would be 30, don't it? But then I give me a 13. I give me 12 and a half. So I work with the 12 and a half. See that? Let's go under the right thing. So it actually was before it for it. So it actually was before it. It's more, you zoom in on it. You see, don't zoom in on here. You see that right off in between, you don't quite reach this line. You're kind of in between this line right here. You don't quite reach it. That's why it is 0.5. So you see the expert accuracy. If you do it again 30, just give me 12.5. That's the only value to be close enough. So this now is 42.5. And that value is your Q3. And so the difference between goes to the interquartile range. Down here. So it will be 42.5 minus 30. Which is now 12.5. All right, answer that one already. Different question this now. 38% of the students, oh, same question. Wow, see another question. For the same graph. Hey, CSEC lazy, you know. Never said one graph mark, one bag of question every year for them. But the point is that they must come back with the same, and again, come back with the same graph, asking something different again this year. And so you have to understand the thing. 38% of the students pass the test. What was the pass mark? 38% of the students pass the test. What was the pass mark? So let me ask a simple question now. I can take this off. I'm going to take this off now, right? Let me take this off. I don't do that part in a different color. Let's do that part in a different color. Let's do that part in a different. Let's use purple for that part, not blue. Yeah. So 38% of the students pass the test. 38% of the students pass the test. What is now? So remember, you know, down here are the ones who get the low marks. Up here are the ones who get the high marks. The ones who pass the test must be somewhere up the top. 30% of the students pass the test, so it must be 30% at the top. All right? All right, so come, work it out for me now. You're gonna know how many students is 38%. 30% of 200 is how much? Huh? 30% of 200. 38% of 200 is how much? Huh? 76. 38% of 200. 30% of 100 is 38 enough. So 30% of 200 must be twice as much. Right? 76. So you want 76 students from the top. What you can do to find 76 students from the top. I find the one who want to fail. 200 minus 76. To show where the top 76 students are. So the top, you'll find the top 76 students up here. That's what you want. Those are the ones who pass the test. The lowest one who pass the test will be the first one in the first one of the 76 at the top. The first one who pass the test. Or you could say the first before him. The first person who didn't pass the test. All right? Either way, you're estimating. So come, do some work for me. Them want to get the thing. I've done half of it for you. 3/4 of it already. I tell them the 76 at the top. So 200 minus 76 gives you the ones who fail. Now listen, look at it this way. 38% pass the test, right? Listen good. 38% pass the test, right? And 38% is 76. Then the ones who failed will be 200 minus 76, don't it? Don't it? The last one who failed the test, the one with the highest mark who failed the test, his mark is a mark that you can't get less than if you're going to pass the test. You're going to 200 minus 76, 200 minus 76 is how much? 124. Good. So the 124th student is the last student who failed the test. Why did he fail? Because he got less than the pass mark. So when you find a mark that corresponds to the 124th student, that is the pass mark. But that is the mark you cannot get less than if you're going to pass the test. Anyway, take it. It was 76 from the top. 76 at the top pass the test. 200 minus 76 is 124. Go to the 124 mark and see what that mark corresponds to. That is the pass. Huh? Want to see the options? The options are these. Down here, son. And then wide enough for you can actually get a good estimate from the graph. These values are wide enough for you to see which one it is. Quick estimate. Hey, touch your young self. Hey, AC too nice. Go outside, man. Come on, let's go. Let's go. Huh? Yeah, come. Estimate it for me. If 38% of the students pass the test, it is 38% at the top. 30% of 200 is 76. 76 at the top pass the test. So the ones who fail is 124. Of the 124, the one who get the highest mark of the 124 is the 124th student. The last one who failed, he got the highest mark and still failed. Of the 124, the 124th student got the highest mark of those who failed, and him still failed. So it means then you have to score more than the mark that he got, or more than the mark that he got less than, in order to pass the test. So find the mark that corresponds to the 124th student, and that is the pass one. But understand that? Good. So 76 at the top we need. So we're gonna do 200 minus, let's do it this way first. 38%. 38% times 200 is 76. 200 minus 76 equals 124 fail the test. 124 students fail. So you're gonna find 124 now. All right, so it's 120 here, so What's the scale of this graph? Get the scale of the graph. And you can't just come and say 120, 121, 122, 123, 124 and give it away. If you read the scale of the graph, watch this now. There are 20 marks inside here, so don't it? And there are 5 lines giving those 20 marks, don't it? Five spaces, 5 intervals, right? So 20 divided by 5 is 4, right? So me said this right here says 124. This 124 that you know. 124. Don't give it away. This is no 124. That is a 140. So this can be 124. Don't give it away. Read the scale properly. That is 124. So it means that this is the 76 students at the top who passed. 76 who passed the test. So the last person who failed the test is the 124th student. The last person who failed the test. And the 76 above him passed. So if 76 passed, 124 failed. So the one who got the highest mark but still failed is the 124th student. So you're gonna see now what mark 124 student got less than. That's why them failed, because they got less than that pass mark. Yep, but understand that? Come across on the graph. Right in the sun. Well, I'm set up nice and easy for you. And come down on the graph and see what that mark is. This is the pass mark. Because 126 students got less than this mark. 40 is the pass mark. You have to score more than that to pass. So 126 students scored less than 40. That's why they failed. 124 students scored less than 40. That's why they failed. The pass mark is 40. Bang. Very good. Beautiful. Next question. Listen, I don't want to just memorize answers enough. And I can change this from 30% enough. I make it be some other values the pass mark. You know? So when I try sort the answers, you know, I try to understand how to do it. So let me keep repeating myself over and over again. Next question over here. Do this one, man. Some work. This question says, diagram refer to cumulative frequency curve for the height of 20 plants. 20 plants, right? 20 plants. These are the heights. Oh, Lord. Come up with something. All right, so it's a 2, it's a 4, it's a 6, it's a 8, it's a 10. Come on, we must know that. You're not idiot. You're not idiot. This is almost 4. 4, 6, 8, 10. This is the same question. Refer to the same graph. This question refer to the same graph. That's what it said. They want the interquartile range. This question for the interquartile. My mistake to go right up with this. They want the interquartile range right here, so guys. What's interquartile range? It's 20 marks, 20 thing. What if I the interquartile range? Q3 minus Q1. So you want 3/4 of Q of 20 and 1/4 of 20. 1/4 of 20 is 5, don't it? So this right here is the position. I want to do it, man. I want to do it. Record interquartile range. These are the answers. Look at it. Let me zoom it up. And then after that, now they want how many students scored at most 45 marks. At most 45 marks. I mean 45 marks is the most. That's a less than or equal to 45. 45 is the most. So this is a less than or equal to graph. That's what this means. I'm not sure the one that we do over here was a less than marks graph. Was a less than marks graph. This one now based on this question is a less than or equal to graph. Because at most means 45 or less. At most 45 means 45 or less. So look at the graph now. Tell me how many persons. On the same question. Yeah, work. Yeah, work. A different. Oh, this must be for the question of why I said so. But you know, that's what I mean. This, you know, the thing get messed up. This is for that question as well. On a different paper. Osh. The thing find its way over here. I don't know what find its way over here. This thing. This question is for this diagram over here as well. Come on, answer it for me. Huh? Can I see what is? See the question here. See the question here. This question is for the same diagram over there that we just did a while ago. Another question on another paper. How many students scored at most 45 marks? The same diagram over here. So. That one kind of easy. At most 45. Same less than 45 marks. 45 or less. So you come here and find 45 and go up on the graph and read it. That's what they want. So look at it for me. Let me take these out. I like leave them on the diagram sometimes. Let me take them out. I don't want that. Same graph I gave on another exam paper and ask that question. At most 45 marks. What do you get? Huh? 45 right here, so. Come up on the graph. Right up to there. You see the line, right? Come up on the graph. Let's see what it makes it. Makes contact right there. Makes contact right here. So this is 160, right? This is 164. And this is 168. So right in between them is about 166, don't it? 166. Huh? So let me see the answers now that is there. There you go. Same question. This question related to the same graph over there. Just that. No, they're up on the wrong page. I look at the thing. My mistake on that document. But understand that? Huh? So this one now asking for the interquartile range for this now. I must say this are 2, right? This are 4, right? This are 6, right? This are 8, right? This are 10. And I want the interquartile range for this now. They want Q3 and Q1. Eh? So how come them can't use? You want to go back for the question as a 45? What is it? Why 34? What do you mean? How many students? See the question here, sir, in front of you? How many students scored at most 45 marks? 34? No, they don't 166 we get from the graph above. See there? 166 the graph tell me. We get 34 from. These are the students, that number of students up there, so. You see the 166, the graph 45 corresponds to 166 clear. We get 34, we bring give it 34. Tell me why you think it's 34? Huh? No, my boss. That's why you have to understand. The graph is giving you that information. That's the problem with QA frequency graph all the time. You're making an adjustment and you don't need to make no adjustment. And CSEC, no, you know. They know somebody will subtract the 166 from 200 and put 34, you know. They know. Listen, put the thing, put the statement to meaning. Put the statement to meaning in your brain. What does that mean? How many students scored at most 45 marks? In other words, how many students get 45 or less? How many students don't get more than 45 marks? That's what I'm saying. How many students scored at most 45, meaning 45 is the most. How many students get 45 or less? That's what it's meaning. You know, mean how many students score more than 45? That's not what it means. If the question was how many students score more than 45, then that would have been the answer. Right? But what does this mean in the English language? It does not mean how many students score more than 45. This don't mean that. You get me? It says how many students scored at most 45 marks. Simply means you want to know how many students scored 45 marks or less. Look back at the graph now. These are the all marks that are 45 or less. Don't you so? See that? Correspond to this part of the graph up here, so. Don't it? Correspond to all the students down here, so. Which there are 166 of them. You get me? All of these students scored less than 45 marks. Them have scored less than 45, less than 40, less than 45, less than. And then maybe some other person or the 166 person scored a 45. Maybe the 166 person of the 200 scored a 45. The question, and that's a good observation, you know, to make, you know. Because another question with the same graph, I just ask you how many students scored more than 45 marks. And someone might memorize this question from Mr. Shaw doing it. I remember so the answer was 166. And the rest of the marks something different now. They can say, but the same question, same diagram, and simply just say how many students scored more than 45 marks. And no further put 166, gonna depend on memory. And that time the answer will be 34. Because that time it will say how many students scored more than 45 marks. So the graph will tell you that 166 scored 45 or less. The rest of them scored more than 45. So if you read the English language in it, I will also understand, guys, that the graph shows you how many scored less than the mark that you see down here. That's what it shows you, right? The graph shows, that's why I'm always in the class, I always put less than on this, or I put less than or equal to on it. All it means is that the year when they asked this question, they were using the graph as a less than or equal to graph that year, same graph. For all the other questions that we did so far, all of these that we did relating to the same graph that CSEC set on all these different papers, they were using the graph as a less than graph. So the graph was showing you how many students got less than these marks. But for the year when they said this question, or for the paper that they said this question, the graph was being used to show how many students got less than or equal to the marks that they see there. That's why they asked this question. But that means 45 or less. You don't have to make any adjustment. The graph is going to show you that number first. You get me? And then you have to go work on the question then. Please, look here. You cannot fully understand these things without actually doing the question. That is how you fully understand anything in maths. By actually doing the question yourself. Not watch Sir do it. Sir doing it and explaining it to you, just bringing you closer to your understanding. But you're still not even halfway there. We bring you like 30% of the way. To go the other 70% to reach 100% understanding, you have to practice. It's almost like somebody can only teach you 30% of what you need to know and set you on the right path. And then with practice and a lot of questions now, the other 70% of the way is covered. I get the full understanding by actually practicing. If you don't practice and put pen to paper and do the work yourself, you're not going to fully understand these things. And so, minute change in that question, you want to get it wrong. Because I don't fully understand it. And that's why some people depend on questions coming back verbatim. Exactly like what we work for. If they make that change to a question, a lot of you run into problems. By depending on memory rather than on understanding. Memory is good enough. We understand might be even more important. And understanding is important for when they make changes to the question. It is your understanding that will allow you to decipher those changes. All right, let me do this one. So the lower quartile is 1/4 of 20, which is 5. So this is the portion of Q1. position of Q1. And 15 is the position of Q3 because 3/4 of 20. That's the position of Q3. Remember, no, those are not the quartiles. You know. I bet you 10 there as an answer. I bet you. No, that's not there. I'm lucky. So to find the quartiles now, you come across on the graph. You reach right here. And read that mark down here, so. That's Q1, whatever that mark is. And come across on the graph at 15. And read that mark down here, so. That's going to be Q3. So what is this mark? You read the scale now. So between here and here, so it's 2. 2 divided by 5 lines. 2 divided by 5 is 0.4. See that? 0.4. So each of these lines is 0.4. See, 0.4. This is 0.8. This is 1.2. This is 1.6. And then 0.4 more give you 2. So each of those different lines is 0.4. You have to get the scale right. So it means that right here, so is 2.4. And right here, so is 2.8. So in between here, so where the quartile is 2.6. But understand that. And then this mark, remember this is now 4, right here, so it's 4. And right here, so is 2, 4, right here, so is 6. This is 4. 4.4, 4.8, 5.2. This is 5.2, right here says 5.2. 5.2. So the upper quartile is 5.2, and the lower quartile, this is the lower quartile. Q1 is 2.6. So the interquartile range becomes Q3 minus Q1. It's 5.2 minus 2.6. That is 2.6. The answer is 2.6 right here. Very good? All right. Next question. I think this one was not very accurate. So I remember about it. But this one says they wanted to find the interquartile range for this one. And CM20 again. This guy same question. I think the value is different. I think this one the graph was not very accurate. The same thing. This is the portion of Q1 again. And this again is the portion of Q3. Read Q1 across on the graph to here. And read it down here. What's the scale? Each of these lines is 0.1 now, because there are 10 lines between 0 and 1. So 1 divided by 10 is 0.1. So right here, so it's 1.2. 1.2. That is your Q1. Then for Q3, up here at 15, come across on the graph. Looks like it is right there. Read it down here. And that is 3.7. See? 3.5, 3.6, 3.7. So this is 3.7. And that is your Q3. So you're subtracting those. So it's Q3 minus Q1 is the interquartile range. 3.7 minus 1.2. That's what 2.5 answer is there. That is it. Very good. All right. The semi-interquartile range for the same graph, semi-interquartile range. Is this interquartile range over 2? See that? What is that? So we'll find interquartile range the same way, but this question is asking for the semi-interquartile range. So a lot of people are going to see the same graph in a question. Remember, say the answer for the interquartile range is 2.5. Don't read carefully. And see that this time they're asking now for the semi-interquartile range. And I'm going to circle 2.5 and say, yeah, that's all. Another question there. Get it right. Come on, I say, yeah, we get that right. Easy. You have to say the 10th time already, answer 2.5. The question name, one simple change, and put the word semi on that, and that different question. Don't give it away. Don't give it away. So the semi-interquartile range is the interquartile range divided by 2. It's the same interquartile range we calculated here a while ago. So it'll be 2.5 again. This is 2.5. So it's now half of 2.5, 2 talking, which is 1.25 is the semi-interquartile range. Asking you something different. The same graph. If you don't see the word cement, you're just dead. You won't depend on no swatting of no answers. Next question. Same graph again. A fish is selected at random. What is the probability that it is at least 1.8 meters long? Say at least. Now, at least means 1.8 meters or more. So the graph will show you how many less than 1.8. That's what the graph show you now. The graph will show you how many less than 1.8. The rest of them, that will be more than 1.8. You understand that? So this at least means greater than or equal to 1.8 meters. The graph is going to show you how many less than 1.8. The rest of them will be 1.8 or more. .8 is right here. Remember, this graph is showing you less than length. So if you want to know how many measure less than 1.8, the graph going to show you. So you want 1.8 or more now, is the rest of them you measure more than 1. You see your upper sum measure more than 1.8. Above with the mark where this is going to give you. So you're going to come up on the graph now at 1.8. It takes up right up to this line right here, this line. I'm going to come up here and read it across on the graph. Right here. You got to read the scale properly. Don't just put 10.2 for that. Or don't put 12. You have to count and make sure. So what is the scale? It's not 1, 2, 3, 4, 5 enough. See, this is not 1. Because there are 10 lines between 10 and 15. So it means every other line is 1. See that? That's not 12. That's 11. See that? 11, 12, 13, 14, 15. Every other line is 1. Make sure you read the scale properly. So this is actually 11. So if 11 of them measure less than 1.8, the rest of them is 1.8 or more, don't it? 20 minus 11. Let me up here, so. That's how much? 20 minus 11 is 9, not it? 9. 9 of them greater than or equal to 1.8 meters. 9 fish. And it's 9 out of 20, the probability of it, right? 9 out of 20. So probability for getting that, 9 out of 20. Well, no 9 out of 11, but I must eat there. Bang. Remember before I started, I said this thing was very accurate. There was something not so accurate on it. 20 minus 3. But you see them add that as 2, but that's not 12. I told you something on this graph was very accurate, if I remember it. That's 1.8 right there. 1.8 corresponds to that. That is 11. 11, 12, 13. Let's go again. 10, 11, 12, 13, 14, 15. That is actually 11. So I have 9 above up to 20. 20 minus 9 is 11. 20 minus 8, 10 minus 9 is 11. So it's 9. But based on that, you have to put this answer. The 8 over 20. This one. All right. Or maybe also set the question, count that as 12. Then full cell. All right. That is it. Next one. Different kind of question now. So with some pie chart, with some cumulative frequency graph, with some histogram. Some different kind of question now. This one says, item 44 of the following table, which shows the result of a survey of 100 persons from two major ethnic groups, P and R. Respondents were interviewed about their attitude towards mathematics. Everybody must love it, because it's the best subject ever. And males don't know that. It says a respondent from the ethnic group P was selected. Listen now, guys. If you're selecting from ethnic group P, it means that you're working with the probability of getting one of these alone, where the total is 60. So your sample space is a maximum of 60. Your sample space is 60. You're choosing out of 60. But you have reduced the sample space to the group of P people, ethnic group P. But that's on that. You're not coming out of the 100 anymore. You're coming out of 60. You're selecting from 60 now. They're working in that sample space, 60. So a respondent from ethnic group P is selected at random. What's the probability that he has a negative attitude towards maths? See me right here, so 24 to 60. See that? 24 to 60. 24 out of 60. That is it. What I reduced to? Try them that reduced to. 12 into this goes 2 times, and 12 into this goes 5 times. 2 over 5. Bang. But I say that? Don't put 24 over 100. Because they're taken from group P. Next one says, a respondent is selected at random. No, you're coming from out of the full set now, out of the 100 now. You're not picking from any particular group. A respondent is selected at random. So this is out of 100 now. Out of the 100. See, the total was 100 now. So this one is coming out of 100. Out of 100. Up here, so it was coming out of 60. Out of 60. Out of 60. I reduce the sample space up there. And what's the probability that you have a positive attitude towards maths? Out of the 100, you're looking for the maths positive attitude. The total positive attitude was this. This is total positive attitude out of 100. But see that? See that? I want all the people who had positive attitude out of the 100 towards maths. Right, so it's 37 out of 100. 37 out of the total of 100, which is 0.37. Right here. Bang. Very good. Next question. Another similar question here, so. Refer to the following two-way table which shows the mode of transportation to school on a particular day from a group of 200 students. A male student is picked at random. So again, now your sample space has been reduced to the male. So that, so this one is out of 108. Out of 108. So you're taking a male student. You're focusing your sample space on the males alone. What is the probability that he does not walk to school? So if he don't walk, it means say mother take the bus or the taxi, don't it? That's 80 out of the 108. But I can see that. 80 out of the 108. So it's 80 out of 108. All right, what is reduced to? Reduce by how much? Divide this down. We're trying to miss it. What have we reduced to? Divide it down by 4 first. Or by 2 or whatever until you get where you get. Looks like 20 over 57, don't it? 20 over 27, I mean, right? We divide it down by what? 4. Good. Next one says, see now, same question. A student is picked at random. So if you want to pick a student at random now from the group, this one is now out of everybody. 200 people now. This is now out of 200 picking, right? A student is picked from the group. You take it from the whole everybody. 200. What is the probability that the student is a male who travels to school by taxi on a day? So you want a male who travels. So it means that this question down and put it in red. Put this part down and says red out of it in there. Red. Put it in red. You want him to be a male. Let's see again. He's a male who travels by taxi. So it means it's right here. So bang. 50 out of 200. That becomes 1/4, don't it? 1/4. What do we go to that? All right, next question. All right, this kind of question now. Bone Johnson. This question says, item 4 refer to the following frequency table which show the time taken by 20 students to solve a math problem. The lower class boundary in the class interval 3 to 5 is, the lower boundary in this class is 2.5. The lower limit will be 3. What will be the class width? What will be the class width? Class width is how much them are going up by. They're going up by 3. Or it will be the upper boundary minus the lower boundary. 5.5 minus 2.5. That will be 3. That will be the class width. See? You can know by looking at all these going up by. It's going up by 3. Class width is 3. But the data is always very uniform. So the lower boundary though is 2.5, right? It's the average between this and that. 2.5, halfway between those two groups. It says now 600, the different question is, or one question. 600 students write an exam. Probability of randomly selecting a failing student is 1/5. How many students are expected to pass? 600 students, 600, it's a 600. Students write an exam. The probability of a randomly selected student failing is 1/5. So the 1/5 fail means a 4/5 pass. 4/5 pass. They're asking how many pass? 4/5 of the 600. No. 4/5 times 600. What I work out to? 480. That's right. That look right, man. 4/5. All right, next one, same thing again. 600 students sit an exam. Probability of random selected student. The probability of randomly selected student passing now is 4/5. Same question, you know. I know they're asking how many students fail. 1/5. 1/5 of the 600 this time, which is 120, right? 120. 1/5. All right. Bang, 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 bang. Next one. If the mean of these numbers is 10, then what is x? The mean of these 4 numbers is 10. What is the x? Yeah, the calculator. Out of these, put them over 4, put it equal 10, and then solve for the x. That's all you have to do. As if you're calculating the mean. How would you calculate the mean? It will be 4 plus 8. The mean would have been 4 plus 8 plus x plus 12 divided by 4 would have been equal to 10. You're solving that for the x. See that? So multiply this over, you say get 40. Now, this one is at 12 and this at 12. That's 24, right? So 24 plus x equals, multiply this over, you say get 40. And so x equals 40 minus 24, 16. Bang. Want to go to that? Next one. When 3 coins are tossed simultaneously, the possible outcomes are these. You can get 3 heads, 2 heads and a tail, a head, a tail and a head and 2 tails, tail and 2 heads, tail, a head and a tail, 2 tails and a head, 3T. Those are the possibilities for real. Those are the possibilities for real. Where H is heads and T is tail, what's the probability of randomly obtaining at least 2 heads? At least 2 heads means 2 heads, 2 or 3 heads, don't it? That's all? What are the ones with 2 or 3 heads? 1, 2, 3, 4. Half then, not it? 4 out of 8. That's all? That's 4 out of 8 probability, which is equal to half. Right here. All right, that. Next one. Put it up on the last one. I don't know after this one. What time is it? 7:30 something. Tomorrow do the last page. That's some people interested in. Can't bother. Next question right here says, item 34 and 40 refer to the following frequency distribution, which shows the average mass in kilograms of a group of children in a school. The lower limit of the median class, the lower limit of the median class is, so the first thing I want to do is find out which class has the median in it. And I will state what the lower limit of that class is. So the question is, which class is going to have the median class? So the median class is the one that's going to be in the middle. How many people are there in it? It says a group of students, so you're going to add up the frequency, add up this. To know which class is in the middle. Class in the middle, or the class where the median would be the median class. And you put the lower limit of that median class. So what is add up to? How many is that? What does add up to? I've added up. 29 plus the 11 here, so equal how much? 150, everything add up to? All right, so the total is 150. So 150 divided into 70 much? 75. So it's 1 to 75. And then 76 to 1 thing, right? So it will be 150, 1 to 75. And then 76 to 150. That's all? Got it. So the median would be right in between here, so right? Agreed? Position of Q2 will be 75.5, right? So the median is in between this group. So we're the 75th. Let's count the frequency now. Cumulative frequency. Cumulative frequency. That's 29 years so. Add 47 to that noise of money. 76. So basically this is the median group then. 75th and the 76th inside us, don't it? So this is the median class. The median is in that class. The median is in there. The median class. And so the lower limit of the median class is this value, don't it? Lower limit. $31. How many children have a mass how many children have a mass of at most 50? At most 50 means less than or equal to 50. Means 50 is the most. How many students have a mass of 50 or less? That are these down so, don't it? Don't it? It will be 29 plus 40. 29. We write it out. 29 plus 47 plus 24. 100. 100 flat. 100 flat. Next question down here. Same information, asking something different. Refer to the following frequency distribution, which shows the average mass in kilogram of a group of children at school. Different frequency. The upper limit of the modal class now. upper limit of the modal class. Modal class is the class with the highest frequency. Which class is the modal class? Huh? Which one? This one, the one with the highest frequency, don't it? This should be the modal class. Modal class. Modal class. And this should be the lower limit amount or upper limit amount. Upper limit. Upper limit. Upper limit is 60. Man. Next one. How many students have a mass greater than 40? Greater than 40 kilograms. No little mix up on this one. Greater than 40. So greater than 40 would be these, won't it? So greater than 40 kilograms, right? So 40 kilograms stop right there, so greater than 40 kilograms. What I work out to? 24 plus 40 plus 18. 82 that add up to? 82. Bang. Anything else? All right, do that one last one for me now. Finish strong. Oh. Do this last one for me. 2 questions. Item 13 and 14 for the following frequency distribution, which shows the average mass in kilograms of a group of children again. The number of children who have a mass less than or equal to 40 kilograms, do that for me. And the upper bound of the median class again. Come on, do that one for me. Do that one for me before you go. Come on, do that. More mass. Too much. Yes. Ready? What? All right. Number of students who score at less than or equal to 40. The 40 stop, right? That's all right. So these 68, that's right? Like easy question here. And about yes, sir. Over here, sir, now. The upper bound of the median class. Which class is the median class? How many people in there total? 132. So it's 132 is what? 66 and 66, right? 66 and 66. 66 and 66. So it means 1 to 66 and 67. 67, 66, 132, 1. So we're talking about in here, so right? The median in between us, don't it? So right, so much reach us 68. So in us then. So this is the median. The median group. The median is in there, don't it? But I'm on the what? Upper boundary, 40.5, don't it? And that? Is that? Yes. All right, guys. Tomorrow, we're doing another part. Hey. Remember now, we have to do over all them questions and send people and do over all the questions, them, you know. All right, bye, people online. See you all tomorrow, same time. We're gonna do the next topic tomorrow. Last topic tomorrow. Yeah, we have one more topic to finish this document. Well, yeah, we have the whole paper on the set.
All right, sir. Later, sir.
Come on, cool. So tomorrow we're doing this.
Yes.
Geometry and trick. Vectors and transformation.
Okay.
All right. Back
Yes,
here
sir.
tomorrow. All right, cool. Bye. See you tomorrow. I'm gonna end it now.